Welcome everybody. It is the exciting to connect with you all on this National Mathematics Day. As CIT, being the active member of Computer Society of India, CSI engages every student with many CSI activities and skills, which is the first largest national body representing the computer professionals of India. The future belongs to those who learn more skills and combine them in creative ways. This is Sindhu from first year CSE department, and I'm highly gratified in welcome you all to today's session panel discussion on mathematics for real life. And I'm delighted to represent the supreme excellence of today's session. My foremost joy to portray Chennai Institute of Technology and my divine gratitude to our chairman, Mr. P. Shriram, for this indelible story in our paths. We would like to show our enormous tribute towards our principal, Dr. A. Ramesh, beloved head of the departments, and all faculty members, our generous support, Mr. Senil Kumar, for paving this way to reach higher spires. Today for show, we are not gonna see the maths which we have in our syllabus. It's a time to reveal the hidden truth of mathematics on this auspicious day. The great Indian mathematician, the man who knew infinity, Srinivasa Ramanujam, a genius who loved numbers, was born on 22nd December 1887 and died on 26 April 1920, which was a huge loss in mathematical field. The gem, the great gem, stone, survived for 33 years. I repeat, the great gemstone survived for 33 years. He is one of the greatest mathematicians was of all time made extraordinary contributions to mathematical analysis and numbers. He demonstrated unusual mathematical skills at school, winning appreciations and awards. At the age of 17, Ramanujan has conducted his own mathematical research on Bernoulli numbers and Hero's Mascronic constant. Government of India has declared that Ramanujan birthday should be celebrated every year as National Mathematics Day, and the year 2012 is observed as National Mathematical Year. His contribution in the field of mathematics has been immense and will be remembered forever. So the true sign of intelligence is not knowledge but imagination. Now I invite Diksha from first year Artificial Intelligence and Data Science Department to take over rest of the session.
Hi guys, this is Diksha from the Department of Artificial Intelligence and Data Science, and also we have our Professor Ms. Sophia Ponmalar ma'am, followed by Manikandan Anna, third year triple, and also we have the second year student Venkatramanan Anna, second year triple. First of all, let me give some brief introduction about this day. Charles Darwin, in the theory of evolution, has said that said about the survival of the fittest, and obviously we humans are the survival of the fittest. And this animal, we humans, has undergone the immense process of evolution. In the present day, the man rules the world, and he has ruled this land for thousands and thousands of years, and now he is ruling this space. This is a great success of us, right? We often say that the factors or reason behind this success is science. While that too, particularly speaking about the astronomy or astrophysics, this guy, physics, takes over all the credits. But unfortunately, we fail to celebrate our hero, mathematics. There is a famous say that mathematics is the language of physics. This guy, mathematics, has been with us right from the calculation of the olden age to the calculation of the distance between the two planets. But we still discriminate the subject, right? Let me share some interesting facts about the maths. We will be aware about the great king Rajendra Chola, right? Could you believe that Rajendra Chola has been applying the concept of conic sections in his army to win the war? Yes, he has used this concept in his army to win the war, and this has been described in the Tamil literatures. In the present day, in the modern world, the entire modern world is running behind the artificial intelligence, right? Just know this, guys, artificial intelligence is not a possible thing without the basic concepts of mathematics. Yes, mathematics has been with us right from the historic period to the present modern world. To elaborate this panel discussion, I would call upon Mr. Venkatramanan, brother, to just take over this panel. Please, bro, the dice is yours.
Hello, folks. I am Venkatramana, and I'm going to, as Subhiksha said, I'm going to talk about how maths is important and stuff. So, starting all, well, everybody from the beginning, they have a pre-minded prejudice that, okay, maths is a difficult subject. This arises from the point that everybody feels they connect the success for a particular question. If they solve a particular problem, they are very happy about it, and they associate that joy to mathematics. That is the reason when we make a mistake in a particular problem, we feel a bit disturbed and we start to dislike the subject. But the beauty of mathematics is far beyond all of this. Okay, I'm going out of the topic here. So I'll start from the basic. In mathematics, there are actually two basic types: pure mathematics and applied mathematics. So in pure mathematics, we find theorems, find proofs, etc. Just for the sake of mathematics. We do it for abstract concepts, for things which do not exist and stuff. There are multiple dimensions which have been found in mathematics, but they are not physics. By physics, they are not possible as of yet. They do exist, yeah. So for applied mathematics is the part which we are more familiar with. Applied mathematics is the part where we apply mathematics for various fields, like in science and engineering, astrophysics, physics, chemistry, and etc. Everywhere it is there. So for my part, the most of what I like about mathematics is the part where we get to see more sequences and codes. I like to see maths as an entire set of codes. This is what drew me to one of its important applications. From the starting, if we see, most of us are acquainted very well with the decimal system. Decimal system, as in, for the people who don't know as of yet, it has the numbers starting from 0 to 9. So every number in the world can be depicted with the numbers 0 to 9. So this is the decimal system. We are more familiar with it. We might also have heard about the binary system, which has just zeros as one, and it has its set of advantages. There are some less familiar things like hexadecimal, decimal, octal, etc. So these are all different number systems. So now when we speak about codes, the most famous place which everybody knows where these codes and sequences are used in the real life is encryption and decryption programs. You might have seen in your WhatsApp calls, you might have seen it in your emails. This chat has been encrypted, or this call has been encrypted. What it means is the data transfer is protected by using a particular code or a key to convert whatever that is, whatever the message is, into a meaningless sentence. And the receiver send again transmits it back to the meaning, and they understand it. So for example, let's just say, okay, I'm talking to you people for a start. So now we are all connected to this particular interface, and when I'm talking to you, the data in this entire thing is transmitted. My audio is recorded, it's sent to you, and then you listen to it. It's not sent in the same form as an audio file. It first goes into the computer. There happens some process in it which encrypts it, and it distributes it to you, which gets decrypted by your computers, and it is returned back. So the key point in encryption is the understanding of the mathematical logic, which tells us how it happens. For example, let's just say there's a popular example of a Caesar cipher. So this cipher, specifically speaking, it is just a shifting of two or more numbers of alphabets in a particular letter. For example, if word T is, if I'm saying the word T, the letter T, then in the data file which is being transmitted after encryption, it will skip 2 or 3 numbers. For example, if it is T, then it skips U and goes to V, etc. So it happens like that. There are multiple ciphers which are used in this particular point. All of them are for data protection. Now I'd like to hand over to Sindhuja.
Now, Sindhuja, if anyone have any questions, you can ask Venkatraman.
Yeah, Venkat, you have a wonderful question from the chat box. Can you explain what is Caesar cipher?
Yeah, Caesar cipher is actually, as I said, it was the cipher which actually transfers a particular letter. In the particular sentence, if we have a particular letter, let's just say A, I can shift it any number of times. The interesting part about Caesar cipher, which I forgot to mention, by the way, is that we can shift any number of letters in any number of patterns. For example, if there is a 3-letter word, I shift the first letter by 2, second letter by 3, third letter by 4. I can do it n number of times. Nobody will know what is the actual message unless they know the key for the encryption.
Okay, yeah, it's a wonderful concept.
Now, moving on, I welcome Manikandan Anna to take on the dais. Please, bro.
Great morning, everyone. I am Manikandan, yes, from third year EEE department, Chennai Institute of Technology. First of all, I thank you all for this wonderful opportunity. Maths is a tool for all the fields of science, and of course, it is a wonderful tool to lead a beautiful life. Everything around us is a science, and that science will not survive without the help of mathematics. There is a saying in Tamil, Panam Pattum Seyyum. Money makes many things, and money rules the world. But without the help of mathematics, can the money rule the world? So I can say mathematics actually rules the world. Mathematics itself is a big ocean. So we can keep talking about its importance for days and night, but we have very less time. So let me to enter into my topic. Nature, our nature itself is a beautiful gift of mathematics. I have an evidence to show how beautiful mathematics is there in our nature. Let me to present my PPT presentation. Sindhuja, are you ready with my presentation? Yeah. Before one page. Go just before one page. Yeah, next page. Okay. I'm going to speak about how the Fibonacci numbers are present in our nature. So you all know what is the Fibonacci sequence. So the Fibonacci sequence in the nth digit in a Fibonacci sequence is obtained by the sum of two successive numbers. That in the sense, the sum of first number and the second number will be the third number. For example, you can see this presentation. So 1 plus 1 equals 2. That is the third digit. And then 1 plus 2 equals 3. That is the fourth digit. And 2 plus 3 equals 5. So like this, the series goes on. So next PPT, next slide. So these Fibonacci numbers are first mainly they are believed that they are used by ancient Indians, but this was first introduced by Fibonacci. He was born in Pisa, Italy in 1175 AD. His full name was Leonardo Pisano. Okay, and then he first introduced this theory. He found this Fibonacci series in the genetics of a rabbit while he is researching in that rabbit family. And then later it is found that this Fibonacci sequence is found in major natural things. Next slide, please. Next. Yeah. You see in too many flowers, there are a number of sepals and petals. But if you count how many petals and sepals, all these the number of petals and sepals will be definitely will be a Fibonacci number. You can see here this flower has 3 petals, and then the buttercups and wild roses have 5 petals. All these are Fibonacci numbers. It will be there in Fibonacci. And then you can see in sunflowers also the number of petals and sepals will be Fibonacci number. Next slide. Yeah, the number of flat sides on a banana may be 3 or 5. So it is a Fibonacci number. You can see that Fibonacci table. Show that Fibonacci table, the numbers. Yeah. So if you see any flower or any banana, the number of flat sides of banana, and then the flower petals or sepal size will be like this only. It will have any of these number only. And then next slide. Yeah, there is a term called Fibonacci spiral. The Fibonacci spiral is made by the. You can see this picture. So by this way, the Fibonacci spiral is made. So this Fibonacci spiral is very common in nature. As we see, the shell of a snail will be like a Fibonacci spiral only. And then next slide. There are many structures that follows this Fibonacci. Next slide. Yeah, the galaxies of universe and the shell of snail, as I already said, and then the shape of air itself is like a Fibonacci spiral, and then in many rhythms of follow a Fibonacci spiral. And then next slide. Yeah, absolutely. The cyclones, we have faced to so many cyclones. The structures of cyclones will be in the form of Fibonacci spiral only. So in all the cyclones, the structure of Fibonacci spiral will be there. So it is used to find the eye of the cyclone, to find the time when the cyclone will hit. So we can find it. And then in quantum atomic theory also, the atom radiates out with the Fibonacci with that structure only. And then next slide. Yeah, there is a term called golden ratio. This golden ratio is obtained by dividing the Fibonacci sequence numbers. So the greater number divided by smaller number. For example, in the table, you may find the first number 1, and then second number 1, third number 2, fourth number 3, like that you will see the numbers. Yeah. So if you continuously divide like this manner, it approaches 1.618. This 1.618 is a special ratio. It is called the golden ratio. This golden ratio is also very common in our nature. So this one in this 1.618 ratio is found in many natural things, like our human body. The organs are placed in our body with this ratio only. Okay, let me explain in next slide. Okay, in this slide, this is explanation how the golden ratio comes. This is a Fibonacci spiral. In this spiral also, it is explaining how the golden ratio is taken. So this larger side divided by this smaller length will give a 1.618. If it gives, means it is a golden ratio. Next slide. Yeah, in this picture, there is a compass for that, and then larger length divided by the smaller length will be 1.618. So if you take a guitar and then check it, this larger length divided by smaller length will be 1.618. And the next slide. Next slide, please. Yeah, here also you can notice that 1.618, the golden ratio. In the sections of ant, you can notice the 1.618. And then next slide. Yeah, in the sunflower, that section, and then next slide. Yeah, that Fibonacci spiral. That Fibonacci spiral is found in the famous Leonardo da Vinci's drawing Mona Lisa. So Leonardo da Vinci is not only an artist, but he is also a mathematician. So in his drawing, he incorporated this Fibonacci spiral so that that picture looks really realistic. And then, as I already said, our sections of body and then the organs in our body are placed with that golden ratio. The distance between our mouth to eyes will be and the distance between eyes to top of the head, if we divide that, it will be 1.618. So the different sections alignment are given in this picture. So the distance between our top of the head to hip and the hip to feet, if we divide that, we will get 1.618. So in so many things in our nature, 1.618 ratio, this golden ratio will be observable. And then next slide. In ancient Greek architecture, they used, so this is a Parthenon of Greece. So this beautiful architecture is created with this exact 1.618 ratio. By following this golden ratio, they have built it so that it is very good architecture. And then in our Egypt, we saw a pyramids. In the pyramids also, we can observe this golden ratio. So in not only this Fibonacci series, so many series are found in our nature, and so many our nature itself contains so many mathematical logics. So everything around us is a magic. So enjoy learning maths. That's all my presentation. Thank you.
That was a great presentation, bro. Now I have a question for you.
Yeah.
Can you explain some of the applications of the Fibonacci series in real life?
Yeah, in the current world also, this Fibonacci series is used in the cryptography concept in the computers, and then it is used for space research, and in genetics also. The Fibonacci series, that sequence and that golden ratio are very useful. And also you can notice that that ratio 1.618 can be used to find the if you want to convert kilometers into miles, you need to divide the kilometers by 1.618. But if you know the Fibonacci series numbers, you can easily convert kilometers into miles. For example, let me explain with the number 55. The number 55 is there in the Fibonacci series. Okay, so if I have 55 kilometers and I want to convert that kilometers into miles, just I need to take the previous Fibonacci number of 55. So what is the previous number? Before 55 there will be 34. So 34 miles will be the answer. So 55 kilometers will be equal to 34 miles. So like this, we can find any kilometer, we can convert any kilometer into mile, and vice versa also we can do. So in the current real world also, this Fibonacci series and golden ratio plays major role, and the mathematicians are working with that.
That was great, bro. Now I welcome Sindhuja to share her views. Please, Sindhuja.
Yeah, thank you. So, maths is hard. Maths is boring. Maths has nothing to do with real life. The most important thing among students is, what is that? All mathematicians are mad, right? But it's not like that. Knowingly or unknowingly, you are dealing your daily life with maths. Differentiation, algebra, integration is not alone maths. Maths is something different. For example, when you go to market, you need to buy vegetables, then you need to calculate in order to save money. That's maths. When you rush up for your work, You need maths to calculate time. When you eat food, you must know maths to maintain your diet, which is related with science. Life is like a maths. If it goes too easy, then something is wrong. Believe me, something is wrong. So, if there is no maths, then what can happen? Think for it. There won't be any thinking power. You will be blank. You will forget how to eat, how to sleep, how to play. Because even that thinking is maths. Now, let's go inside the magical square. Let me share my PPT. Yeah, he's the Srinivas Ramanujam who created the magic square. So, see here, just admire for the rest 2 minutes what I'm going to show for you. See, the sum of numbers of each row is equal to 139. 22 plus 12 plus 18 plus 87 is 129. 88 plus 17 plus 9 plus 25 is equal to 139. Also, 10 plus 24 plus 89 plus 16 is also equal to 139. And the last row, 19 plus 86 plus 23 plus 11 is also equal to 39. I request you guys to take your calci and just verify this. The second part, all the sum of each column is also equal to 139. Then, the sum of numbers of each diagonal is also equal to 139. Interesting, right? There are some more to go. Let's go. See, the sum of numbers identically colored is also equal to 139. 22 plus 12 plus 88 plus 17 is 139. Like that, all these squares. See, the next one. Sum of numbers identically colored is also equal to 139. See how many steps we are getting for the same answer. And the next one. And the next. See, the sum of numbers identically colored is also equal to 139. Now, you are having a surprise. Let's see what's that. See, the first row of this square is the date of birth of our great mathematician, Srinivas Ramanujam. So let me stop sharing my screen.
Now,
okay, let me continue. So, despite of the age, everyone loves to hear a story. So, let's go to have a small story. Listen carefully, okay? So, when Ramanuja heard that Hardy is not a place, this professor in England had come in a taxi. He asked him what the number of the taxi was. Hardy said that it was just a boring number. It's just 1729 something. So Ramanuja replied that don't say like that. 1729 was not a boring number at all. It was a very interesting one. He explained that it was the smallest number. I repeat, the smallest number that could be expressed by the sum of two cubes in two different ways. That is, let us perform the calculation. Take your calculator or any calci app in mobile. Just perform the simple operations I say. Now, add 1 cube plus 12 cube. Answer your reply in the comment box. You will get one answer. Just keep as it is. Don't see. Now, add 9 cube plus 10 cube. You will get one answer. See what the answer you got at the result. You get 139 for both of the questions. So, yes, that's 1729, which is the smallest number that could be expressed by the sum of two cubes in two different ways. So 1 cube plus 12 cube is also equal to 1729 and 9 cube plus 10 cube is also equal to 1729. So this story is very famous among mathematicians. So 1729 is sometimes called Hardy Ramanujan number. Remember, Hardy is not a place, it's professor's name. See, whenever there is a problem is given using alphabets and numbers, it's not alone maths. You will be facing problems in your real life too. And if you are able to solve that, then I'm damn sure that you are too strong at maths. Maths may not teach us how to add love or how to subtract hate, but it gives us hope that every problem has a solution. Like Max, in our life, problems are meant to be simplified and not to be complicated. Over to you, Subiksha.
Hey, that was a great speech, yeah. Now, if anyone has the questions to can please.
Is there any questions in the chat box?
Okay, Sindhuja, I will ask you a question to you.
Yeah, I'm ready.
Good. What are the basic need that one must have in order to learn maths?
Okay.
Answer in a single word.
Wow, what a wonderful question. Is of course it's willingness.
Why are you saying it's willingness?
Because confidence is a skill, but not willingness. Willingness is a try. When we never fail to try, so we need to try. We never need to stop trying. So that's what I said. It's willingness. Willingness is a try, and we never fail until we stop trying.
Okay, nice answer. And guys, if you have any questions to ask, feel free to ask. Put your questions in chat box.
Over to you, Subiksha. You can continue. Okay, let Venkat continue his speech.
Venkat, I think you muted your voice.
Am I audible?
Yeah, now audible. You can continue.
Yeah. So Padmasaran was asking what is the application of integration. So we use integration in various ways. We use integration to find the area which is under the curve. The use of that particular point is we find out the improbability. Let's say, for example, in probability, when I'm finding all the possible cases which can happen under a particular constraint, I draw the axes according to the variables in the particular scenario. I draw the curve according to the points which I get for each and every circumstance, and then I draw the graph. For that particular graph and the particular function, I substitute the points which are all possible to satisfy that particular condition. When we integrate the particular side which has all the points which satisfy the value of the function which is necessary to find the probability of the particular point or the particular scenario for the thing to happen, you can find it by integrating the area under the curve. So if you do it like that, you get all the points, all the possible outcomes for the particular experiment.
Wonderful
this is one of
answer.
the few application for integration. Okay, Sweta M is asking what makes you to learn maths. For me, maths is well, I want to learn maths because I'm just curious about it. Simply enough, for each and every question, every time I try to solve it, I try to do it from a normal method, the way it is prescribed in the textbook and stuff. I try to do the formula and everything. Then I start wondering, okay, why is this working? Why can't I do it like this? We all have learned basic differentiation and partial differentiation and stuff. So how many of you have tried it at home to find the solution of partial differential equations using differential equation methods? The way we solve differential equation method. These are all the small things. If we try all these things just for the sake of curiosity, I'm not going to get a lot of what to say, actual benefit in case of marks and etc. But it helps me feel better. Okay, I know a little bit more about this part. So just for the sake of curiosity, it makes me want to learn maths. Okay, Subiksha's here. Over to you, Subiksha.
Yeah. Now I'm going to explain you about the application of mathematics, application of statistics in the area of data science. Okay, we all know that statistics is the collecting and analysis of numerical data in large quantities, especially for the purpose of interfering proportions in a whole from those in a representative sample. So, with the help of statistical data, we would be able to take surveys like the countries with the most selfie-related deaths, the state with the more death rates. These kind of surveys would be able to take with the help of statistics. Now, I'm going to explain you about the application of statistics in data science. Statistics play a major role in the upcoming field of data science. For example, data analysis requires descriptive statistics and probability theory at a minimum. These concepts will help you to make better business decisions from these data. Key concepts include probability distributions, statistical significance, hypothesis testing, and regression. Now, here is another example of using the statistic in the area of data science. Just consider the cricket player Ashwin. By keeping the data of wickets which he has scored here, yet now, and if we are able to predict the wickets that he is going to take in the next match, and this estimation is known as data science. For predicting this, we require two basic concepts in mathematics. One is statistics and another is probability. This is regarding the application of mathematics in the field of data science. Now I welcome Sindhuja to explain the applications of mathematics in her field. Please, Sindhuja.
Yeah, thank you, Subiksha. You know one thing, mathematics is the language with which God has written the universe. Does anyone know why is mathematics vital to thrive in your AI career? Okay, let me say. The future we have seen in science fiction movies here. From virtual reality to functional gadgets, AI has invented our lives in ways that no one has ever seen or expected before. AI tools and chatbots have been on the verge of breakthrough in the prompt evolving tech realm. AI is not magic, it's just mathematics. The ideas behind thinking machines and the possibility to mimic human behavior are done with the help of mathematical concepts. Artificial intelligence and mathematics are two branches of same tree. And if you want to thrive in your AI career, you need to study mathematics. Merely being a fan of science fiction won't be enough, right? If you are going to build an artificial intelligence career and dominate hiring in the space, be friends with mathematics and it will rock your world. I used to think to excel in artificial intelligence career, which is our destination, maths is the pathway, right? But why maths teachers are so genius? Then why they are not into that career? Then I realized if they become, then there would be only one genius. But if they teach their knowledge, then see, they are giving billions of new lives by sacrificing their lives. We are so grateful to the man, Srinivasa Ramanujam, who made the maths easy, and to the man, our beloved teachers, who made our lives easier through maths. Let's dive deeper into the fascinating realm. Artificial intelligence problems constitute on two general categories, search problems and representation problems. Following them, they are interconnected models, tools like rules, frames, logics, and nets. All of them are very nearly mathematical topics. So let's go into an example. Consider self-driving cars. Their goal is to recognize objects and people in video images. That is mathematics behind these cars in the form of minimization procedures and backpropagation. Mathematics helps AI scientists to solve challenging deep abstract problems using traditional methods and techniques known for hundreds of years. Don't think it's a pressure. It will increase your mental endurance. Mathematical concepts gives the real solution of hypothetical or virtual problems. Like wherever you go, if someone asks you any question, You are supposed to reply them, right? Reply in a reliable manner. That's the most important thing. That reply is also max. Ask why? Because you are thinking what to reply and what to reply in a reliable manner, right? That's known as logical thinking, which is max. It's story time, I think. So just dive into a story. Imagine you are in a closed room. A passerby slips a sheet under your door containing a list of questions written in Chinese. The bad news is you don't understand a word of Chinese. But it's good. At least you found that's Chinese. And the good news is, can anyone guess what's the good news? Okay, let me see. There is an instructional manual written in English that guides you step by step to convert the given characters to a set of new ones that corresponds to the answer. So after converting, they are giving that list of paper to the passerby. The passerby receives the answer and he is convinced you that you understand Chinese. But see the concept. You have just translated, but there is no meaning in that, like you haven't understand it. So similarly, in your school days, you just perform linear algebra, differentiation, calculus, probability. You just perform that, but you are not trying to understand for what we are reading this. That's the mistake you made. So remember, these linear algebra is the mathematics of the 21st century. Don't forget the three main branches of mathematics that constitute a thriving career in AIR: linear algebra, calculus, and probability. Why are you living an ordinary life when you can live an extraordinary one? But you can't wish for a better life, right? So go out there and create it. See, the task ahead you is never greater than the strength within you. So if you wish, then everything is easier, and one among that easier is max. So over to you, Subiksha. Please unmute your mic, Subiksha.
Thank you, Sindhu. Hey, that was a great speech. And now moving on, I welcome Manikandan brother to explain about the role of mathematics in his field. Please, brother. Manikandan?
It seems he's having data problems. Okay, fine. So as we are talking about the subject of mathematics in the engineering field, I believe all of you are well acquainted with the mathematics in your particular departments. You would actually get angry if I start talking about it right now. Yeah. So now I'm going to talk about something different, something which makes people want to like mathematics. Simple logic. Let's just say, how many of you know to play Sudoku? Okay. Oh, I'm sorry. I didn't actually start the poll or something. Just a sec. I'm new to this, so I don't know how to start it. But anyway, so yeah, Sudoku is a game with which involves basic logic. The point of Sudoku is to actually fill 9 digits, 9 numbers, all the decimal numbers, except 0, in a particular line. So the point is there are 9 boxes. Each box has 9 units inside it. So there should be 1 to 9 in a particular row, in a particular column, and in each box. Just a sec. Yeah. So that is the logic of Sudoku. So Sudoku, it might not seem at the beginning that it is related to mathematics, but in what we have seen the basic logic in Sudoku in multiple formats. The concept of anybody, any answers? Okay. Okay, so yeah, So the point I was trying to make was that Sudoku involves basic logic just like maths. There are multiple games, multiple puzzle games and stuff like that which involve mathematics, small puzzles which involve mathematics. You don't have to solve complex problem to be a mathematician. All you need to do is do simple things, simple logical problems, which will help you improve your logical thinking. The more logical thinking you have, the more easier maths will be for you. Is Manikanda here? No. So, okay, I had just planned a small question, which was about the Caesar cipher, which I mentioned earlier. So I'm going to type in the question. I want someone, if they understand what the message, encrypted message in Caesar cipher is, then you can please type it in the chat box. Yeah, so this is a Caesar cipher, which I mentioned in my first when I was first speaking. So in this particular Caesar cipher, I have shifted the alphabets with the factor of 2. So if you can decrypt the following message, please put the answer in the chat box.
I think it's an interesting task to our attendees.
Anyone get the answer yet? Yeah, Padma Saran is asking a question. I'm not understanding. You just typed the letter A. I'm not asking.
Yes, I think he has answered to the poll.
Oh.
You guys first finished Venkatana's question, then I will relieve the answer.
இல்ல எனக்கு இங்க நீங்க பேசுறது எதுவுமே தெரிய மாட்டேங்குது. நான் உள்ளதான் இருக்கேன். நீங்க உள்ள இருக்கீங்களா வெளியில இருக்கீங்களா?
Yes, Padma Saran, if you finish the answer, please type it in the comment box. Yeah, so Padma Saran got the answer. The encrypted message was actually, this is a cipher. I missed the is in that particular sentence. I'm sorry. So yeah, so this is one of the very basic ciphers. This was developed by Julius Caesar. So it's like way before we were born. So there are multiple ciphers which are possible, multiple ciphers, multiple codes which are there in the present day world. If you are interested in them, you can search them up in Google. It's a very interesting field. The field of encrypting and decrypting using sequences is very interesting. The fun part about it is you get to see codes which are not yet seen. There are multiple questions out there in the internet which they give a particular code. They don't give you the key for the answer like I did to this question. I told you that it was Caesar cipher with the two letter shift. So in some codes, they do not give you the key for that. The thing I told, the 2 shift, is the key to the particular message which I had given in the chat box. So if we know the key, then for decrypting it is easy. But if you don't know the particular key, you have to try all the combinations. And that's what makes it more difficult and more fun when you finally find the answer. Okay, guys. So as we are under a time constraint right now, I would like to hand it over to Sindhuja.
Yeah, that was a wonderful thing. My first job is to do searching in that quiz you gave. That's the very wonderful, so interesting, amazing one. Thank you, Venkat, for that. So I have gave the poll to you guys. So the answer for that poll is E. I repeat, the answer is E because state 1 you have E. In 3 also you have E. And in 5 also you have E. So every odd number has the letter E. This was the one question I gave you. Yeah, over to you, ma'am.
Yeah, actually, it was very interesting. I see people being more focused on your interest. Okay, as Venkat Raman said, he was very curious. I say that being curious to learn, which is very important, to learn new things. Not only in the field you want to shine, but also in the field you have passion about. You can have interest to learn new things in day by day life in each and every moment you do. And that's what is necessary, I could say. You students seem to be very much more interested in the mathematics, and it will surely motivate the first year students too. It is 100% sure, I can say. And also, as you talked about cryptography, I'm thinking about this vast subject I have studied in cryptography in my college days. It was a big thing, big deal, but it is an interesting one. And cryptography, as we talk about cryptography, we have the current trending thing called cryptocurrency and Bitcoin. As you know, everything involves mathematics. And so I say it is very important to have a passion on mathematics in whatever field you go. So let us just wind up with this. I think every one of you have shared your questions and views. Manikandan, can we wind up now? I think Manikandan is not present. Venkatraman, is it okay? Is it over now? Can we wind up the session?
Yes, ma'am. So, okay, guys, we'll see you later in the next webinar.
Yeah, ma'am, we can wind up now.
Yeah, okay, sure.
Okay.
Thank you, students.
Thank you, folks. Bye.